That's
Awesome. Thank you. Sorry about that.
Thank you.
All right, thank you, Sunny. All right. So before we get started, can you guys see my screen?
yes.
Yeah.
All right. So we're just gonna get you guys acquainted with what our lesson plan is, or structure, tentative structure is for the next couple weeks. This is just so you guys know what you're doing, and just something to look forward to as well. So last week we just did over like Python basics. You guys went over print statements, some variables. We have some. So this is the simplified version, by the way. We have I'll share the more fleshed out version, and there's some activities in here that we put in that we may or may not do. So just to get that out there. So last week we just started. This week, so in this lesson, we'll be focusing on some control flow stuff. So if else statements, loops, and why they're important. And then you can browse through this whole. I'll send a different doc. This is just simplified, just so I can share for the meeting. But we'll be going over data structures, so like lists, how do you like file handling. So this is using your data, making it readable, um, working with data so you can, use it in Python essentially. Um, and same thing with week 5. We'll be looking more into libraries as well. So like importing libraries, using libraries in Python. Week 6, we'll go into like graphing the data, visualizing the data, that sort of thing in Python, of course. And then week 7 is when we'll start working with machine learning models. We'll get more. So last week we did some concepts of machine learning. We're gonna cycle off that just a little bit, and then we'll hop back into this week 7, hopefully. And we might do it a little up here as well. But week 7 we'll start diving into that, and then start building the models, using the models, utilizing them as well. And yeah, there's a doc I'll share to everyone that is more detail as well. And then after week 11, so by week 11 we'll be able to use um, different models using the Python libraries. And week 11 we'll start the competition part of the program. So we'll start prepping you guys for like what a hackathon is, how to go about it, brainstorming, making teams. And then week 12 is when we'll start, or week 11 too. Week 12, week 11 is when we'll start actually that little project, that hackathon that we'll call it, using what you've learned to solve a problem, do a prediction, observations, anything like of that sort. And yeah, we'll have judges and everything. It'll probably be us. So yeah, if anyone has any questions, feel free to unmute now or not. Send an email or anything. That's about it. And yeah, any questions on that?
No.
No? Okay. Um, let's see. So we'll start off with a quick overview on control flow right now, and then we'll get into an icebreaker after that. So let me pull that up. Okay, let's see if this works. Oh, it's the share button. All right. So what is control flow? Control flow is basically like we're introducing paths in our program. So it's the how we make decisions, how the program makes decisions uh, with anything, right? So like it's how
Wait,
you and
wait.
I make decisions in real life.
Oh no,
So
we can't see the slideshow. We just see. Did you hit slideshow? Or
let me see.
maybe it's opening in a different window that's not shared?
Maybe.
Yeah. So, or you can just keep it in the regular view.
Is that good?
Now it's good. Okay, thank you. Cool.
All right, cool. All right, we'll start again. So what's control flow? It's how our program makes decisions. Just like how you and I make decisions with everything we're doing, the program will do the same thing, and you just have to make the path. That's what control flow is. So for example, when I wake up, if it's 8 a.m., I'll hit the snooze button, right? If it's 9, I'll get up and start, rushing to do things. Kind of like that thing. And at the same time, we can also repeat certain commands and It just makes it easy for our program to make decisions, essentially. So, like I said before, oh, there's no visual on this one. I don't know where it went. But like I said before, one aspect of this is conditional statements. So like the statement that depends on a certain condition. So you literally what I said before. It chooses different paths based on a certain condition. For example, is the temperature above 30 degrees Celsius? If that's true, so if yes, then turn on the fan. If not, open the window. So in our program, we'll literally write, if this certain case happens, then run this portion of the program. If not, then run a different portion, right? So if I can think of another example, if the front door is open, lock the door. If it's closed, don't do anything, something like that. Um, yeah, and if I guess we can do the same thing as we did last week. Does anyone want to in the chat type in like an example of that? Can I don't think I can see the chat while I'm screen sharing. No.
You can, but it's like work. Oh, yeah.
Oh, I can get it. Yeah. All right, so anyone can just unmute or type in the chat just an example. Let's get like two examples going. Or yeah, two ideas of like a conditional statement. All right, I'll throw another one out so we can get the idea. If like it doesn't need to be okay, someone typed in one. If it's raining, take an umbrella. If not, don't. All right, that's a beautiful if statement, right? If I throw one out there, if I'm hungry, I'll eat. If not, I'll go for a run, right? Um, that's a weird one, but if we can get one more for someone, that'd be amazing. Again, you can unmute. If you unmute, that's even better. Like and I'll call out someone too. I know y'all got brains. I'm not gonna lie. This is not a tough task. We make decisions every day, no? All right, Najib, I'm gonna point you out. You tell me, can you pose a conditional statement? Oh, someone else did it in the chat. If you studied, you will pass the exam. If not, you will fail. All right, that's a decent one. All right, cool, cool. I'm happy with that. Najib, I'm gonna pick on you next time. Don't even worry. All right. Okay, so the next type is a loop. Um, for example, if you want to like loop something over and over again, you want a portion of the code to run multiple times, whether that's a fixed amount of time or just until a condition is met, so a requirement is met. So the first example is a for loop. And if this is going over your brain, we'll be going into it in more detail right after this little presentation. But so like a for loop is how many like you have a specific amount of times you want to repeat a piece of code, right? So if you have like again 10 apples in a basket, right? For each apple in the basket, wash it. Or like for like if you want to repeat a certain code 10 times, right? So it's like I want to open and close the door 20 times, you would use a for loop. You can use that with you can do that in Python. You don't have to like write it like, okay, open the door, open the door, open the door, open the door 10 times. It's just like you can just do it in like a couple lines. And then another type is a while loop. So like with the conditional statement we had before, it kind of like loops that concept in. So like while the light is red, we'll wait. Or while the light is green, press the gas. Or while I'm hungry, continue eating. Um, yeah, so Najib, I'm gonna pick on you again. Um, can you give me an example of something like a loop? Yeah. Oh, we got some other examples from before. If I go to the park, I'll bring a ball. If I go to school, I'll bring a book. That's a decent one. And then we got if you are tired, or if you're tired, sleep. If not, stay awake. Yeah, these are all good. All right, Najib, he said, while it is dark outside, stay sleeping. All right. Some of you be doing the opposite, I'm not gonna lie. It's night outside, y'all just staying up playing games. So I'm guilty too, not gonna lie. All right. think all right. And then why is it important? So that sounded like a little bit of like, obvious like if this and this, yeah. But without control flow, um there's no decision-making process in our programming, right? And as a programmer, you would have to write, or it would run every line that you wrote. And sometimes you would write, like, if you want to take the case, for example, it's like, okay, if it's raining outside, I'm going to bring an umbrella. But if we don't have control flow, it's like every time, no matter if it's raining outside, no matter this is, you're bringing the umbrella outside. Or like if you like just it's like it's like bringing your house to everywhere you go. You don't need everything. It'll just slow you down. And then you'll get like unnecessary, and then like there's some things where you don't want to happen, right? But you have it in your code for a specific case that never happens, or sometimes happens, right? But with control flow, we can control whether or not, like depending on a condition, something will happen. Um, yeah, and then we have another example. If it's vegan, skip the meat. Okay, I don't know what I was writing there, but I was writing it a little bit. Yeah, anyways, like if you're vegan, skip, don't, hold the meat. That sort of thing. Um, Yeah, so then essentially control flow lets your code like react to certain data as well, make choices on its own, and like with the loops, handles repetition very well. Yeah, and then if anyone has any questions, put them in the chat. But yeah, any questions? Are we feeling good? All right, let's see. I'm thinking of a question right now. All right, I got a question for everyone. We'll go down the list, or we'll just go down. All right, no one has questions. That we very confident bunch of group of people. Okay, if you had an extra hour today, for example, like after your whole day is done today, you had an extra hour. What would you do with it? Jump Uncle, can you go first?
Sorry, can you repeat that? It broke up a little bit for me. You wanted a question?
If you had an extra hour today, so you're all done with everything today, but you had an extra hour, and you got that extra energy during this hour, like at the end of the day, what would you do?
I'd probably practice music. Yeah, playing music, right?
All right, and then we'll go ahead with um, Fatia. What would you do with that extra hour?
I'd read.
That's a good answer. Tanisha, what would you do? Play video games, valid. Okay, Tassia, what would you do?
Play video games.
All right, and then Shahid and Faris.
Hi,
I would want to read.
I would want to read a storybook.
A storybook, okay. And then Shine, what would you do?
I would probably play basketball.
Okay, that's us. Okay. We finally got some physical activities going on. All right, FK, what would you do? Exercise, I like that. Naji, what would you do?
Yeah, an extra hour of sleep.
Okay, yeah, we all need that, don't we? Fatima, what would you do?
I just take a nap.
And then Zafir, what would you do?
I would ride my bike.
And then Ryan?
I'd probably go to the gym.
And Zahin, what would you do?
I'd probably get an extra hour of sleep.
And then last but not least, Ahnaf,
I would sleep.
sleep. And then if any of the other mentors wanna say what they do with an extra hour, if not, I'll go next. All right, they don't want to share. I think I would hit arm day low key. All right, and then okay. And then I don't know if we have a lot of if you wanna can we get some like reactions to see who's in the who's in the upper group last week or who's interested in the upper group who's wanting to go there.
Well, last week, like I thought I wouldn't know much like coding, but like I pretty much like knew everything in the beginner group. So should I go into like the advanced one?
Yeah, so so here's the situation with that. We're splitting up for now, but we're also gonna mess around with how it would be if we do it together and
Yeah.
then split it up with like when we do activities, that sort of thing. So if we can get like some like reactions going on, just so I can visually see like the makeup today, because I think we have less people, yeah, overall. I know it wasn't just FK last week there. So all right, one, two, and then Najib was there, three, and then Zafir's interested, four. Hmm, who else was in there? Was there anyone else? Five. All right. Okay, and then six. Okay, that's basically everyone. So who's not part of that group? Let's go that route. Okay. Okay. All right, let's do this. So since the group's not two, we one, two, three, four. Okay, I think so part of the plan was we do split it this week just so I can gauge the upper groups. I think we'll still do that because it's still like 50-50. Shiny, you good with that?
Yeah, sounds good.
Okay, let's go ahead and do that. Um Jobs uncle, can you make breakout rooms?
I guess. Yeah, let me do that.
Yeah, so then if you're so for the this class, what we're gonna do is I'll go over. So we're gonna go over like for the upper class, we'll go over variables right now, control flow, but we'll go a little bit faster, just a little bit faster, and then we'll do a like I want to give you guys an activity, and then we'll just basically just gauging how far you guys go. If we do it quick and like you do it like proficiently, then we'll move on a little bit, and then I'll have like a challenge for you guys to show me next week.
So I'll do one room and other people will stay here. Is that what you guys do? Or two
Yeah.
breakout rooms?
Just one breakout room, and then so the kids who are gonna go with me will go to that breakout room, and then everyone else will stay in the main room.
Okay, and do we let everyone choose what room they want to go, or do you want to assign them?
They can choose, but I think
Okay,
yeah, is it easier for you to assign them?
I mean, we can do both. Either. If you want to assign, you can assign, or I don't
Okay,
know.
no, they can just join whichever they want to.
Okay, cool. Sounds good. And I will call
Just
it.
curious how the recording works. Like this separate record separately, two rooms.
No, it records just the main room or whichever one
Okay.
counts. Then I think, yeah.
Okay.
What should we call the other room?
Group one, group two, doesn't matter.
Maybe a better name. Like, are you do covering? What are you covering in the other room versus this room?
Same thing, but I'm gonna try to more gauge them a little bit, do more like activities with them, just so
And then you're going to the other one, or Cheyenne?
I'm going to the other one.
Okay, so I'll
The
call it
breakout room
Ornop's
is more
room.
experienced people.
I see there is a comment about the what type of who is gonna go to the. Is there breakout room for the people with more experience? Yeah, somebody responded. Okay.
Okay, now we have Ornop's room.
All right,
And
the breakout room should be open. Feel free to I'll be in there. And if Jumps uncle or anyone who sees someone who should be in there, just push them in there.
that's the more advanced one, right? Okay, oh, whatever. People go to the rooms you want to go.
Okay. Yeah, that's the more advanced one.
Okay.
All right.
Jamshed bhai, so we should go to split in and go to another room.
There's two rooms, I guess. The other one is the advanced one, where they'll
Okay.
cover a little more stuff, and this is the not advanced one.
Oh, okay.
Yeah.
So I can keep continuing here or move to
Yeah.
other group, right? Or maybe can you move to the other group?
Okay. I'm also gonna try and go to the other room, but Mainul bhai, you can stay in this room, whatever you want to do.
Yeah, but who's gonna teach mentor be here? Mentor, who's gonna teaching here?
I think Cheyenne.
Shan, okay.
Yes,
Okay.
yes.
Okay.
Okay, let me share my screen.
Actually, I'll stay here.
Okay, can you guys hear me good?
Yes.
Okay, so today's agenda, it's a lot more than last time. Last time we just went over variable types and the print function. Today we have a lot more on our agenda because we have a little bit more time as well. So this is what we're going to be focusing on. We're going to do a quick review of the things we learned from last time just to make sure that we don't forget it. We're going to go over some different types of operators like arithmetic operators and comparison operators. We're going to go over some new functions as well. Last week it was the print function. This week we'll be introducing the input function and we'll also be introducing the range function. We'll be going briefly over if-else statements. I know Ornov covered a little bit with the control flow earlier, but we'll go into how to incorporate that with Python. We'll also be going over for loops, and we'll learn how to define functions today, just very briefly. And at the end, if we have time, we'll do a quick little activity, just a little guessing game. All right, so let's get into it. Um, just to like make sure you guys remember, keep your brains fresh from last time. Do you guys remember what the print function did in Python? If you remember, just like answer in the chat. Like just like a brief little description if you remember what it did. And, I'll wait for someone to respond. If not, that's fine. I'll go over it again. Print function is something that prints a sentence. Yeah, essentially, right? It's how we basically print text to our screen in Python. Yeah. Another question I had for review from last time is, do you guys remember what the difference between an int and a float was between those two different variable types? There was a small difference. I want to see if you guys remember what it was. Again, answer in the chat if you can. Yeah, exactly. Int is the number and float is a decimal. Yeah. And the last question I had for review was, what are the only two values a bool can output? So if you remember, like the bool variable type can only output two values. Yeah, true and false. Exactly. So let's go over arithmetic operators really fast. Just because I'm sure you guys are pretty familiar with these already in like your math classes and stuff. These are the four very basic arithmetic operators. We have addition, subtraction, multiplication, and division. For multiplication, when you're coding in Python, you want to use the star, which is above the 8 number on your keyboard or whatever. And for division, you want to use the slash. So, and this works the exact same way it does, like how you do in your math classes, right? Like when you're coding in Python, 2 plus 3 equals 5, like 2 minus 1 equals 1, things like that. But here are some of the more complicated, or like, yeah, a bit more like syntactically focused arithmetic operators. We have exponent, we have floor division, and we have modulo. Exponent, I'm sure you guys are familiar with that as well. Like 2 to the power of 3 equals 8. So how you would write that in Python is 2, and then you would use 2 of the multiplication symbols to make it a power in Python. So if we're like, let's open up Colab. I'll give you guys a second to open it up with me. But the way you do it is 2 and then 1, 2. And that would be equal to 8, right? And that's essentially how it works in Python. You want to use 2 of those star symbols. And then for floor division, this is important because it helps you round down to the nearest whole integer. So basic division, when you have 9 divided by 2, that would give you a floating point value, right? A decimal. That would give you 4.5. But with floor division, instead of 1 slash, you have 2 slashes, and that essentially rounds down. Instead of 4.5, it rounds down to 4. And lastly, we have modulo, which is the percentage symbol above 5 on your keyboard. Essentially, this is a remainder. So we know how remainders work. Like 9 divided by 2 is 4.5, but realistically, it's 4 remainder 1, right? Because 4 times 2 equals 8, and then you have a remainder of 1. So modulo essentially outputs the remainder of whatever you're dividing. So 9 percentage 2 equals 1, because the remainder of 9 divided by 2 is 1. So let's do a little short pop quiz. What value do you guys think would be returned using the floor division operator in Python for -12 divided by 5? And remember what the floor division operator does. It rounds down to the nearest whole integer. So we're working with a negative here. Keep that in mind. Just answer in the chat view. Okay, so you would think it would be -2, but yeah, actually it's -3 because -12 divided by 5 would be around like -2 point something, right? But since you're rounding down to the nearest whole integer, remember negatives go down, right? Instead of -2, it would be -3 because you're rounding down. And for my next question, what value would be returned using the modulo operator in Python for 83 modulo 4? Yeah, 3, right? Because 4 goes into 83 like 20 times and the remainder is 3. So yeah, that's what the output would be. Okay, now let's go over the input function. The input function essentially asks the user to type something into the program. It shows a message, which we call a prompt, inside the parentheses, and whatever the user types is returned as a string, a type string. And it doesn't just have to be a type string. We can convert it into a type int or a type float, and I'll show you how to do that. And we can save the input and store it in a variable later for like later use, you know. And here's like the general format of like how the input function would work. We would set our variable name and we would assign it to input, and then inside the parentheses, we would have our prompt message. So let's go to Colab and I'll demonstrate that real quick. Let's assign a variable name. And remember this equal sign is for assignment. It's not actually equal to the value, it's just assigning the value after it. So let's assign it input, and then let's put parentheses around it. Follow along if you guys want to, but Let's see. What is your name? And then what we can do is we can print the name after that, whatever the user responds. So it will prompt me like this, what is your name? And then I'll just put Cheyenne, and then we can print out the name that I write from the input function. So that's just a brief little overview on how it works. Essentially, it takes in input from the user, it asks the user something, and then whatever the user like inputs, we can display that, right? And actually, let me briefly go over how to convert into a type int or a type float. An example of this would be, all right, let's say you're asking someone for their age, right? So let's write a variable named age. Let's assign it input. How old are you? So the issue with this is that input on its own would return a string. So when we print age, like if we say something like 8, like it'll print 8, but this will be returned as a type string instead of a type int or float, which is what we're looking for. So what we want to do with that is to make it turn into a type int. We can do that by putting int at the beginning of our input function. And this essentially, instead of having it output a string of 8, it'll return an integer of 8. So it'll look the same, but it's very important to have that distinction of what you're returning and what type you're returning. So yeah, it'll return 20, but this is again of type int, not of type string. Now we can go over some comparison operators.
I just wanted to ask, are people using Colab? Like, are the students, or how many of you are using Colab now? Just to get a baseline of like, are you coding right now? Can you give us a thumbs up or something? Yes? Okay. I see 2 yeses. I code right now. Okay, cool. Please try it, doing this as Cheyenne is also doing it. Just wanted to.
Yeah.
Okay, sorry for the interruption, Cheyenne.
No, all good, all good. And of course, like let me know if I'm going too fast or anything in the chat. We have a lot to cover today, so I'm trying to go through it, but if I skip over something or if something doesn't make sense, if you have any questions, please ask away. So now we'll be going over comparison operators, and this also is similar to like what you've seen in like your math classes with some subtle distinctions as well. So comparison operators, like what we're familiar with, right? Some like equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. All of these, they return bool values. So again, remember, like you guys said from the beginning, right? Bool values are either true or false. So when we use a comparison operator, we're essentially doing it to return a true or a false value. And one thing I wanted to know is the the syntax for the equal to. Notice how there's two equal signs here. It's not just one, right? Because the one equal sign is the assignment operator, which we use to assign variables and such, right? So that's a pretty important distinction to make, because when you're setting something equal to something and you're comparing the two values, you need to make sure it returns a bool value. You need to make sure you're not assigning something to something else. So yeah, the double equal sign, that's for equal to, that's a comparison operator. And the not equal to, the syntax for that is exclamation point equal to, and then greater than, less than, greater than or equal to, less than or equal to. I'm sure you're all familiar with, and we know how those work. So next we'll move on to like if else statements. This one might be a little hard to grasp, so if you guys have any questions, again, ask away. Um, if statements essentially help the computer choose what to do next. It's like making a decision, right? Like from what Arnob said earlier. When Python sees an if, it checks whether the condition is true or false. If the condition is true, it'll run the code you see under that if statement, right? So like in this format here, if this condition is true, then you follow the code line after that, do this condition. And if it's not true, Python will move to the next condition. And we can add extra checks using this term here, elif, which stands for else if. If none of those conditions are true, then Python runs the else block here as a final option. So our program reacts differently depending on what's happening, just like how we make decisions every day, right? So let's go over an example in Colab. For example, let's assign a value age to like 20, right? And I don't know why it's doing that. Okay, there. Let's do a comparison for this example. Like let's use a comparison operator. If age is actually let's assign it to 18. If age is greater than or equal to 18, actually let's assign it 21. If age is greater than or equal to 18, so here's the format. If and then this age is greater than or equal to 18, this is your condition. And you want to end with a semicolon at the end for a good syntax. And make sure you're indenting for the following line. Let's write a print statement. Print, you can vote. Because if you're older than 18, then you can vote, right? And else, followed by the semicolon again, indent, or yeah, print, you can't vote. So essentially what's going through here is we assigned our age variable the value of 21, and it's gonna compare the age variable in our condition to this greater than or equal to 18. If that's true, it'll print you can vote. If it's not true, then it'll print you can't vote. So let's run that, and then yeah, you'll see it can print you can vote. And if we change the age to 17, it'll print you can't vote. So that's like a very brief on how if-else statements work. If we want to incorporate the elif statement, like I mentioned earlier, then we can do that by, let's do a quick example of like temperature, for example. Let's assign temperature the value of 80 degrees or something. And let's say if temperature is greater than 85, we'll print something like it's hot outside. And instead of just using one if and one else block, we can use elif like this. Elif temperature, oh, sorry, temperature is greater than 75. Print it's, and then we can finish off with our else statement. Else, if it's anything less than 75, we'll print it's cool side. So because we assigned our temperature to the value 80, what do you guys think will be outputted here when I run this if elif else block? Will it print it's hot outside, it's warm, or it's cool? Because remember, this satisfies both conditions, right? This satisfies if temperature, or this satisfies the which condition? Does it satisfy? Just answer in the chat if you can. Yeah, right. It'll print its form because it'll go through the first condition here. If temperature is greater than 85, it'll compare 80 to 85. Okay, it's not greater than 85, so we're not going to print this. We're going to go to the next block. And we see that it's greater than 75, so it's going to print its form. Exactly. And you can see when we run it, it'll print its form. Okay. All right, here's a short little pop quiz. What will this code print? So here we assigned x the value of 10, and then we have a few comparisons to a few values. So will it print A, B, A, or B? And remember, the value is 10, so it satisfies both conditions, right? It's both greater than 5 and it's greater than 3. So what do you guys think will be printed here? And just answer in the chat A, B, or C. Okay, so I see we're getting some, okay, people are thinking you're gonna print A, B, but yeah, the answer is actually B, right? And that's because when you go through an if-else block, it stops, it satisfies this first condition, so that's what it'll print. It doesn't continue throughout each um, block. It stops at the first block it satisfies the condition for. So in this case, x is 10, and that's greater than 5, so it'll only print A. And we can see that if we exit. Like we'll go through that right now. Like in our temperature example, right? If I change the value to 90, it's only going to print it's hot outside. It's even though it satisfies both conditions, that it's greater than 85 and it's greater than 75, it only runs through the first if block. So yeah, that's pretty important to note for the future. Next we'll go into for loops. Um, A for loop is essentially when Python lets you repeat code for a certain number of times, like again, Arnav described earlier. Each time the loop runs, we call it an iteration. And for each iteration, it will go through the code block that follows it. So in this format, you'll see the syntax. We have for whatever variable in a certain sequence will do something. And that for loop will just loop over and over again. It'll execute this something block for each variable in the sequence. And this can be really useful, right? To help avoid writing the same line of code over and over, which is really inefficient. And it's very important as a programmer to be as efficient as possible. And it can also be used with the range function, which we'll be sticking to for our purposes today. And the range function, it creates a list of numbers that Python can count through one by one. It starts at 0 by default, and it stops before the number you give to it. Now, that's just with one parameter. I'll show some examples in Colab. But I also wanted to talk about break statements real quick. A break statement is essentially when you're in a loop, and it's a command that immediately stops the loop. Even if there are more items or iterations left, when Python reaches that break statement, it jumps out of the loop completely. And again, I'll show examples for all of this. Okay, so let's go back to Colab and let's do some examples working with for loops. Okay. So the range function, let's do that real quick. The range function essentially works like this. It's a built-in function Python has, and if you write it like this, range parentheses, and you give it a value, an integer value, and then it will count. It'll start at 0, and then it'll work up to the number you give it, which in this case is 6, minus 1. So if we use it in a for loop, for example, for I in range 6, make sure you put a semicolon after your for loops. You want to let's print hello. And this is the general format of how you want to write your for loops. You have for some variable. I just named it I, but you can name this anything. You can name this number, you can name it num, you can name it anything. But for our purposes, I'll just use I, the letter I. For I in range 6, print hello. So you'll see the output of this is it'll print hello 6 times, right? And what this is doing, um, this isn't a part of the code or anything, but uh, when you're going through a for loop, for each iteration, it'll go through like since our range is 6 up to 6, you'll start at 0, so iteration 0. And that iteration 0, it'll print hello. And then you'll go to iteration 1. You'll loop back again. You'll see, okay, print hello again. And then you'll loop back again for iteration 2, 3, 4, and 5. And it doesn't iterate to 6 because remember the range function, it prints up to the number. It doesn't print through the number. So it won't print 6. It'll only go through the number 5. And it starts at 0. Now, let's do an example with the break command. Um, let's do, for example, for I in range 5. Remember to put the semicolon. Oh, sorry about that. Let's use a conditional here, right? If I is equal to 3, let's break out of the statement. And then we'll print I. Or yeah. So you'll see here what happens is instead of iterating through the entire range, right? Because our range is 5. So normally it would go 0, 1, 2, 3, 4. But because we have this break statement incorporated and this conditional that says if I is equal to 3, we break, then we break at the value 3. And it stops before that value is ever printed. So we only have 0, 1, and 2. So that's how break works. It breaks out of the loop at whatever point you want to set it to. So in this conditional, we set it to 3, but it can be set to 4, it can be set to whatever. And you'll see that it breaks out of the loop before it goes all the way through to range 5. Okay. Here's a short little pop quiz. What will the following code print? For I in range 6, print I. So look at the answer choices and answer in the chat which one you guys think it is. Okay, I'm seeing a lot of D's. And yeah, that's correct. It is D. Some people might be inclined to choose either A or C because you think you're printing the letter I 6 times, but that's not the case. We're iterating through a certain range, and when you iterate through that range, you are printing the numbers in that range. So that's correct. And of course, the distinction between B and D is that D starts at 0 and B starts at 1. And the range function always starts at 0 unless you tell it not to. And I'll go over that briefly right now. The range function, it can start at a different number. And we can do this by um, going to the parentheses right here. And before this number 5, we can start at 1 instead. So if we do range parentheses 1 comma 5, what we're telling it is we want to start at the number 1 and go up to the number 5. So let's erase that. So we'll see here that instead of starting at 0, it starts at 1. So the normal range function only tells us we only have to tell the range function like until what number we want to go up to. But if we add that little 1 at the beginning, and this can be 1, it can be 2, it can be whatever, we're telling it where to start from. That's what this first number does. And the second number still does tell it where to stop. But that's an important distinction to make. The range function, it can work in multiple ways, right? Okay. So yeah. Yeah, got the pop quiz. And now we'll move on to function definition. Here we'll kind of put everything that we've been like learning so far together and we'll try and define a function. The functions that we've been talking about so far, right? Print, input, range, these are all built in Python functions, meaning Python has already defined what they do for us, right? The print, like, we don't have to tell print, like, write this message out. It already does that for us. What we're going to focus on today is defining our own functions. And again, this is all for the sake of efficiency, right? To help organize our code and avoid repetition. Instead of like writing the same thing over and over again, if we define it once in a function, then we can just call the function and we don't have to write it over and over again. So when we do define a function, in the parentheses, like how the format works is we define it and then we give it a name. And then within these parentheses, we give certain parameters or inputs. We can return like, and then underneath that, you can write whatever code you need to execute. But yeah, we can optionally return results to the program, but this is how it generally works. You write def, which stands for define, right? And then the name, whatever function name you want to give it, and then the parameters inside the parentheses. You don't need to have parameters, but that that is the case a lot of times. So let's do a brief overview. Let's go back to Colab and let's define our first function, right? Let's define a function def. Let's just make it say hello for now, right? And we don't need to pass anything into the parameters list for now. But yeah, let's just define a function say hello. And what we want this function to do is say hello, right? So what we can do is, okay, so we can just say print hello. And how we can call that function, right? Because that's what you're supposed to do when you define a function, you want to call it somewhere else. You want to just do say score. And you want to, when you're calling the function, you want to make sure to use these parentheses. That's really important because if you run it without the parentheses, it won't work properly. So to call the function, say hello. Oh, it expects a, oh, that's my bad. I forgot. This is why it's important to remember your semicolons, but yeah, it'll print hello here. And this is like this when we're talking about efficiency, right? This helps us with our efficiency because instead of having to write a bunch of print statements where you write print hello a bunch of times, you can just call say hello every time and it'll just print it for you because you already have the function defined beforehand, right? And if you want to do an example with parameters, what we can do is we can define a function, let's say we're defining a function named add, and we want to pass in two parameters that we want to add, A and B, for example. And what we want to do is in this function, we want to print A and B. We want to get the value that we get from adding these numbers together, right? Because that's what you do when you add. I think we'll end in like about like 5 minutes. We're almost done. This is like the la I had an activity, but we can do that. We can save that for next time. Yeah. So, when we call the function, it's not just the parentheses this time because you have parameters. You want to put something in the parentheses that you want to add together, right? That counts for A and that counts for B. So let's put 3 and 4. And these act as A and B from the parameters that we defined earlier. So if we do that, you'll see we get the output of 7. And yeah, that's how parameters work. That's how function definition works, just as a baseline. And I was going to have us do a little activity, but it seems like we ran out of time today, which is fine. We can do that activity next time. But it's important to note that defining a function doesn't run it. We need to actually call it by name, right? So we defined it, but after that code block, we needed to call it. We needed to write say hello. We needed to write add, and we need to pass in the parameters. So you can't just define a function and expect it to run. You need to actually call it for it to run. And again, just for formatting purposes, always make sure your indentation is proper, right? Like when you're writing a for loop or anything, for I in range 6, make sure you indent or make sure you put your semicolon and then you indent in the next line because that's important for formatting purposes and organization and just general. That's how Python code works. And yeah, essentially that's it. And we'll save this activity for next time, but essentially what I was planning to do is we'll define our own function called the guess game, and then we'll kind of incorporate all of what we've learned so far with the for loops, the if else statements, and different variable types, the input function, the range function, and we'll build a game where we let our user guess a secret number, and then we'll give them a few tries to guess the number. We'll tell them if it's right or wrong, and we'll stop if they guess correctly, and then it'll print game over when they're out of tries. So we'll save this for next time, but just to give you an overview of what we'll do next time. And yeah, that's pretty much all I had for today. So if you guys have any questions, ask them now. Otherwise, I'm basically done.
Question.
Have a question? It doesn't look like anyone has any questions. I'll give it a minute or two.
That was really nice, Cheyenne. Thanks for walking us through
Yeah, no problem.
all these control statements. Do you think the other class will join back here before we end? How does that work?
Yeah, I think I'll let Orno know that we're pretty much done here and we're out of time.
Okay, let's see if they join back. When do we end today? Okay. How's everybody feeling? Does anyone want to talk, say a few words, turn on their camera? No. Hey, Arnav's back. Do you guys, okay, are you coming back, everyone coming back to this room or?
Oh, I low-key just let him go.
Okay, cool. All right, I guess here also, I think the students are still here. If we want to finish the class today, we can do that.
Okay, and let me I shared the Discord to the other group. I can send it here too. So this is not a pressure for anyone to join, and if everyone, we'll send it again next week or in an email. But this is just for the students and just the students to interact with each other, paste their code in, questions, not related to this, just anything, but mostly just to so we can upload code, ask questions, that sort of thing.
Yeah, that would be a good idea. So folks who are not joining the class directly like that, but may watch the video, maybe they would be able to ask questions on that Discord, right? Okay.
Next thing, yeah.
Okay. Thanks. I'll let them know because at least two of the kids they said they didn't join the class, but they watched the video and they liked it. They said that they'll ask questions.
All right, cool.
Alrighty. See you guys next Sunday. Thank you.
Okay, bye.
Thank you, guys.
Bye.